We will now move to our next keynote speaker of the day, Dr. Elisabeth Bix. I'm delighted is able to join us. Elisabeth is a Dutch-American microbiologist who's worked at Stanford University for many years and also in industry. Since 2019, she's been a science integrity volunteer who scans the biomedical literature for papers for looking at images and other areas of concerns. And she's reported over problems in over 6,000 scientific papers. For work on science communication and exposing threats to research integrity, she received the Peter Wildey Prize, the John Maddox Prize, and the Ockham Award. Elisabeth, it's great to have you here with us today. Thank you so much for joining the conference.
Thank you so much, James. I will set up my screen. And I hope you can see my screen. So yes, I have a background in microbiology, and I'm currently a science integrity consultant. And before I start talking today, I want to make sure I declare all my disclosures, because we're talking about integrity, about openness. And so I want to ensure that I have disclosed how I am making my money. I'm not employed by any university. I'm my own boss. I'm a consultant. And I earn money by giving advice to universities or scientific publishers about science integrity or science misconduct cases. I've also worked at a company that is currently in the US being charged with insurance fraud. So I have 4 patents from working at that company, but they're not going to make me any money because this company is now bankrupt and charged with insurance fraud. And I wasn't involved with the fraud, just making sure that that's out of the way. I also get some income through Patreon, which is where people can support my work. I don't say that here to ask you for money, but it is a source of income. And it actually allows me to spend most of my time voluntarily, so unpaid, except through Patreon, looking for problems in scientific papers. And I'm by far not the only person doing this. There's many others who donate a lot of their time searching for problems in published papers. So after a paper has been peer-reviewed and published, there can still be many problems or even misconduct in these papers. So I have shown a couple of their Twitter accounts. Most of us are on Twitter, and we communicate with each other. And we all have our own specialties. Some people work on plagiarism, some people work on citation mishaps, and I work on image problems. And so most of my talk will be about that. And why do all of us care about scientific papers? Because you might think that if a paper has been published and peer-reviewed, that it is set in stone, that there's no problems left with it. But that's not the case. But we scientists talk to each other and build upon each other's work by looking at publications. So if we see scientific publications sort of as a brick wall in which each publication is a brick or a building block, we scientists build upon each other's work by citing other people's work and by doing literature searches. And we tend to assume that each of these publications are set in stone, are the truth, because science is about finding the truth. And we tend as scientists to trust each other. But if one of these publications or building blocks, one of these bricks contains an error or contains even fraudulent data, that might mean that we scientists try to reproduce that data and we might not succeed. So errors or even fraud in scientific papers are hindering science because they waste a lot of time. We might waste a lot of time trying to reproduce these results. And if they're built on error, if they're based on scientific fraud, they are not the truth. So science integrity is everything that science should be, and science misconduct is everything that science should not be. So we tend to trust each other, But science as a field, unfortunately, is not immune to fraud. There is fraud in science, and we heard already a little bit about that in Sir Patrick Vallon's talk. So in the US, and I think in most other countries, science misconduct is defined as one of three things: plagiarism, so copying or stealing somebody else's text or ideas without giving credit; falsification, where people maybe change the values a little bit to make the data look better; and fabrication, where a person might completely make up results. So those are the three pillars or the three flavors of science misconduct. And what is causing people to do misconduct? Because I do not think that anybody starts a scientific career by thinking, let's do fraud. It's usually created by an atmosphere in a lab or in a company. So I can think of three different scenarios that could drive a person to do fraud. So first of all of us scientists feel the pressure to publish. Publications are often used as a measure for our productivity. And if you put a lot of pressure on people to publish, then people will maybe be tempted to make up results, because it is much easier to publish positive results than negative results. And of course, as we heard before, pre-registration of a clinical trial is a good way to ensure that even negative results are published. But very often in biomedical sciences in particularly, it is just more attractive to publish positive results. And so this could lead people to make up better results than they actually obtained. A second scenario that I think of is the taste of success, as I call it. A successful postdoc who has in their research maybe accomplished a Nature or Science publication, and then moves on to a position of a professor. But because they changed fields a little bit, their topics is maybe a little bit different, their results are not as great as before, but they feel this expectation and they have tasted success. And so they're really eager to still publish great results. And this might be a scenario in which a person is tempted to cheat. And the third one, also touching upon what Sir Patrick Vallon told us in his talk, is that there's this hierarchy in academia. A professor has a very powerful position, and people working in his or her lab are maybe subject to the power play that a professor could do on their staff, on their junior graduate students or postdocs, because all of us need this letter of recommendation, need this publication. And if you are a junior person and your professor is really demanding of certain results and maybe even threatens to fire you, you might be in a situation where you're tempted to do misconduct, again, to produce results that are better than you actually obtained. And so these three situations sometimes are, of course, connected to each other, but those are all situations that could lead a person to do misconduct. Now, what I specialize in is looking at images in scientific papers, and in particular biomedical papers. Since I'm a microbiologist, I am molecular biologist, I would see photos like these. And so if you think of a scientific papers, there could be line graphs, there could be photos, but all of these images in a scientific paper are the data. And images are powerful. We tend to believe if we see it, right? So if we see images like these, and all of these are fine, none of these are fraudulent, we can look at these images and see that they're unique and they're identifiable. And so what I look for are duplications, or even signs of photoshopping. So all of these images are fine. And these are images that you can tell each of these bands apart, even if you don't know exactly what we're looking at. These are images of protein blots or DNA gels or tissues or nanostructures. We can look at these images and we can see patterns, and we can see that all of these images are unique and we can tell them apart. But there's also cases where there's duplications. And so these are the things that I specialize in and that I look for in published scientific papers. So here's an example of what I call a type 1 duplication, which is two duplicated panels. So you see a bunch of panels here. Each of these are photos of cells. And as you can see from the labels, there's supposed to be different treatments and time points, but there's two panels that are identical. So it's the exact same photo being used twice to represent two different experiments. Now, this simple duplication, the exact same photo being used twice, is usually an honest error. This is not scientific misconduct in almost most of the cases. But it's still an error, and it's maybe not an important error, but this should be corrected. So I reported this to the journal, and this got fairly quickly corrected. So a correction was issued for this paper, and now the correct photo is included. So that's usually not misconduct. But moving on to a different type of duplication, in this particular image, you see a bunch of overlapping images. So it's not just the same photo, there's a shift under the microscope, and you can see that there's lots of overlapping photos here. This is beyond what I think is an honest error. I cannot make the call if this is misconduct. This is up to a journal or to an institution to investigate. But in this particular case, the journal agreed with me that this paper was beyond a correction, and this paper got retracted. I would not trust anybody, or nobody should trust these figures to base your own research on. So I think that's a good outcome for science. Here's another example of a type 2 duplication, so a duplication with an overlap. In this case, we're talking about a mirroring and a stretching, so that could happen as well. And these mirrorings and stretchings are very suggestive for an intention to mislead. So this might be misconduct. Unfortunately, I reported this a couple of years ago to the journal, and this has not been addressed yet. So here's another example and of a duplication. And in this case, this is a type 3 duplication. So now we're looking at a photo in which elements of the photo appear to be repeated. That's a type 3 duplication. That's a very suggestive for an intention to mislead, very suggestive for science misconduct. So if you look at this particular figure, you might see that a particular lane that you can see here once is actually taken out and maybe photoshopped and just duplicated many times, involving mirroring and stretching and what else. So this is very suggestive of an intention to mislead. And the journal agreed with me. This paper got retracted. Here's another example. I mean, you can find many of these examples in scientific papers if you know what to look for. So here's a lot of duplicated elements, type 3 duplication, very suggestive for an intention to mislead again, and retracted. This took a couple of years to get this paper retracted, but finally the journal did that. Here's another example of a type 3 duplication, lots of duplicated elements here. This is supposed to be an electron microscopy photo of nanoparticles. Unfortunately, this paper is still out there, and it's actually cited 179 times. So 179 other researchers might have based their research on this particular figure. And I reported this to the journal editors, but it's still out there. Nobody would know that there's an issue with it, except that I found it and I reported to the journal. So that's bad. The journals do not seem to respond very well. And here's one of my favorite examples. So here's two photos published in a paper suggesting that there was a laser treatment that could remove brown spots from people's faces. So on the left, you see the patient before laser treatment, on the right, 6 months after laser treatment. But it seems to be the same photo. The brown spots are either photoshopped out or in. I don't know really that, but the guy is wearing the same shirt. His hair and his face and all the fine lines are exactly at the same spot. So this appears to be a case of photoshopping, but it took a lot of convincing the editors that this was a photoshopped photo. There's more examples. Here's a flow cytometry image, lots of duplicated elements here. Unfortunately, again, the journal did not respond. And you can find these type 3 duplications also in all kinds of spectra, where you have like a lot of noise and some peaks, but in this case, the noise parts appear to have been duplicated. This paper got retracted. And so I have done lots of looking at images in scientific papers, and I found that when I did a scan of 20,000 papers spanning 20 years, spanning 40 different journals and 14 different publishers, that I found 4% of these papers to contain a duplication like these. And we estimated that about half of these, so 2%, contained a duplication that was suggestive for an intention to mislead. Of course, I need to be careful and not call out any fraud. I want to make sure that I don't cross any legal lines. But half of these papers, so 2% of papers, appear to contain some intention to mislead in just looking at the photos. Now, if you think about how easy it would be to change a line graph or a table, that would just, involve some drawing, and it was much easier to mislead a person by changing data in a line graph than in a photo. So the actual percentage of misconduct might be much higher than 2%. I've only looked at photos. I imagine there must be much more misconduct going on. So if you think that maybe 5 to 10% of papers could contain misconduct, that is a very scary number. And very likely, if you are a researcher, that you've come across a paper that contains scientific misconduct in this paper. Now, this set of papers, the initial papers that I found in my initial screen, so around 800 papers, gave me the opportunity to look at what happens when you report these papers to the journals. So I reported all of them to the journals, but unfortunately, after waiting 5 years, 2/3 of these papers had not been corrected or retracted. That's, I think, a big, that's very bad. You would expect science to be self-correcting. You would expect journals to respond to these allegations, but they don't. They don't react in the majority of the cases. 27% were corrected and 7% were retracted. There's a tiny sliver of expressions of concern. But yeah, in the majority of the cases, nothing happens. By now, I've moved on. I've actually reported more than 6,000 papers. But again, I've seen in this much bigger data set that 2/3 of these papers are not reacted upon. So if we have to wait for journals to respond, how do the institutions do? Well, they don't do much better either. They like to swipe things under the carpet. In many cases where I reported it, like figures like these, where there's multiple cases of duplications, no fraud or plagiarism was found. And it's in many countries that we see the same picture, that the institutions tend to keep these things very quiet and do not want to acknowledge that there was science misconduct. But that's not serving science. That's just protecting the guilty and protecting your own reputation, but it's very damaging for science. So I've decided to put all these problematic findings on a website called PubPeer, because I feel we need to share. If we find a problem in a paper, we cannot rely on the publications, on the publishers and the institutions to attack or address these problems. I want to share that there's a problem with a paper. So if you go to pubpeer.com, you can search for papers that have been commented upon. So you can comment on any paper you like, as long as it's polite and objective. It's heavily moderated. And that's the best we can do. So there's many of us who scan the literature for problems, and we post on PubPeer. And we hope that you install then the plugin that they have, so you can do a literature search and see that certain papers have been flagged. And I've posted around 5,000 papers now on PubPeer, and I'm still working on getting all the problems that I found on there. So can we use artificial intelligence maybe to solve this problem? Yes, I'm spotting most of these duplication by eye, and of course software can do a much better job, but it's a harder problem than you might think. But many people are working on using some type of software, some type of artificial intelligence to find these duplications in figures, and not just within a paper, but across all papers, sort of like plagiarism of images. So I'm starting to use some of these software. But of course, we can artificial intelligence also can be misused, not only to find these problems, but also to generate fake photos. If you're familiar with thispersondoesn'texist.com, it is a machine learning type of AI, artificial intelligence, called Generative Adversarial Network, GAN. And GAN technology just uses a library of noses and hairs and skin types and mouths, and it just generates a new face every time you hit refresh. So these photos look fairly realistic, and so it's pretty good in making a photo of a face. It's actually not very good in making cats. So I've noticed there's a website called thiscatdoesnotexist.com, or these cats do not exist. So GAN technology is maybe not very good in generating photos of cats that look realistic. It looks like parts of cats, but not a real cat. But if we think about how easy it is to generate a face that looks realistic, it's much easier to generate photos of protein blots. So these are Western blots, and they look fairly realistic. But if you look carefully, we found a set of papers of 600 papers that all used the same background. So these were generated, we think, by paper mills, scientific paper mills, which are companies that make fake papers and sell authorships to people who need to publish a paper. They're very rampant in countries where these types of publications are used to generate monetary incentives, where people get money when they publish. They will then buy authorships to get a fake paper. And in this case, the paper mills made the error of making all of these images the same background and sort of generate these sort of unique, like tadpole-like images of protein bands. So we call this the tadpole paper mill. And we've worked on this with a bunch of people, and I've listed their names and pseudonyms right here. So sort of as takeaway points from just me looking at images, there is a lot of misconduct if you know what to look for. And it's most visible, obviously, in images. And images are data. So it's even, you cannot really say as an author, oh, it's just a figure. No, figures are the data in a scientific paper. And I think the real percentage of misconduct based just looking at photos is between 5 and 10% of papers. I've talked a little bit about why do people commit misconduct. And I do think as a field, we're just focusing way too much on productivity measurements by looking at the number of publications. We should allow negative results to be published. We should focus on other contributions that scientists make. If we just focus on productivity measurements by looking at numbers of publications, we are driving people into doing misconducts. I've noticed a little bit of the conflict of interest, where publishers and institutions seem to be sort of unwilling to address these problems. And it's up to maybe us as volunteers to detect science misconduct, but that should not be the case. Publishers, we pay a lot of money to publishers to get our papers published. They should be doing much more quality control and much more recall after a problem has been noticed after publications, and they're currently just not doing that. I hope that people like me, whistleblowers, are somewhat legally protected. I'm not protected by any university because I work by myself, and this work could financially ruin me. I've already been threatened with 2 lawsuits by researchers who didn't like what I found, and there's probably more in the pipeline. I still think it's a fight worth fighting for, and I'll keep on doing this because I think it's very important. But we need this to be a profession that is actually rewarded instead of being threatened with legal suits. And then finally, there's a tremendous cost of science misconduct, not just for the scientists who are trying to replicate those results, but for science as a whole. We've seen in the past 2 years how science has suffered in trustability. And I do not want you to walk away from my talk thinking that all science is flawed, because you could easily misuse my findings by saying, well, we cannot trust science anyways. Science should be trusted, and science is the only way out of the problems we're currently facing. But we need to do better in self-correcting science. And with that, if you like the duplications, you can play the game image forensics with me, where I just remove most of the labels, and I'll make it about having a little bit fun, finding the duplications. And then the first one to post the right answer will win an emoji award. And with that, I thank you, and I will take any questions. Thank you.
Elisabeth, that was fascinating and slightly scary at times, but also I'm very glad there are some, a lot of positives there as well. And the fact that this isn't just, this is a systems problem. There are factors within the research system that can incentivize these types of behaviors while people bear personal responsibility for the actions that they take. There's a lot of positive measures in place. And I think echoing, what you said ties into Patrick's talk earlier and other speakers yesterday about sort of openness and a willingness to confront problems head on and talk about mistakes more openly will also contribute to a culture where fraud is both seen as less acceptable and actions taken to address fraud can be taken more easily. So thank you so much for that. Lots of great comments in the chat and lots of very positive thoughts about what we've had to say. So a variety of questions here. Right. Do you see the value in investigating historic allegations? And do you think there should perhaps be a time limit to the number of years we should look back at these issues?
Right. Yeah, that's a good point. I think it's never too late to correct science, but we also have to think about the sort of the limit that you can find the real raw measurements.
Yes.
If you think about a paper that was published, I don't know, 30 years ago, nobody really expects that raw data to still be there somewhere. I mean, you might be lucky, you might find an old notebook somewhere in a dusty basement or so, but in many cases, doing science obviously takes a lot of note taking and generates a lot of material, and a lot of books and binders and everything now is digital. But I cannot even access, things on a floppy disk that I put there. Like, there's also a limit in the accessibility of digital data.
Yes.
So it's very often, usually you have to keep your data for about 6 to 10 years, depending on the organization you work for. But after that, it becomes very hard. But having said that, I do feel there should be a limit on the time that a journal or an institution should take to investigate these cases. We've seen with many cases and important retractions that there's 12 years, for example, with the Wakefield paper, there's 12 years between the paper being published and the paper being retracted. Yeah. And this should have been a much shorter time. And so there should be a limit there.
Thank you. I think you've also just answered, well, partially answered another question who was asked, can you ever fully investigate image manipulation if you've no access to the original? So if you didn't have access to the originals, or, if it's electronic and, the floppy disk, the zip disk, whatever, can't be read anymore, we've all had that problem. What standards would you look for in order to reach some sort of conclusion if you can't access the originals at all?
Well, when there's cases that have severe image manipulation, it's important to know that there were no originals, right? There were some originals, but the originals are not going to look like what was published, because what was published was photoshopped. So usually the author will claim we lost the original in some catastrophic event. So they will always say, oh, there was a tsunami, or there was a fire, or there was something destroyed my data, because they know that original data is going to show that they photoshopped. So the authors very often will use some excuse to not have to produce that. But you can require that original data need to be sent along with papers. So this gets a little bit technical, but you can think of raw data, or like files where you can see what the microscope took. The photo of the camera of the microscope has some format, and you can see if there was tampered with, or what were the processing steps done on that image. You can think of all kinds of things, but people who want to do fraud are going to do fraud on those raw data as well. So it's very hard to look at these images and find originals. But in some cases, it's so obvious that it's photoshopped. If you see copied elements within a photo, you should, as a journal, already be retracting those papers, even if there are no originals.
Thank you. Okay, Gavin mentions an example when early in his career he came across a paper that claimed they derived a sample size calculation from the previous paper, and he happened to have that previous paper to hand and could see that they'd, in his view, deliberately misreported what was in the previous paper to make something that was illegitimate look legitimate. He always regretted not doing something about it. If individuals encounter the situations you described or have suspicions that something may be out, what would you recommend individuals do?
I would currently recommend to do two things. So post on Papier, you can create an anonymous account, and it's very anonymous, doesn't log your IP address or anything. You will be assigned the name of an organism from the tree of life. I say it's usually a fungus, but some microscopy image, some microbe. But you should also write to the journal. And in both cases, when you report these things to the journal and on Papier, keep it very objective. So don't yell misconduct or fraud. Just say this image looks very similar to that image, or I believe this data was misrepresented because this is what this one paper says, and this is what they stated in their paper, and there's just a disconnect between the two. But don't make any accusations. That will keep you out of legal trouble, and it will also show the editor that you're not emotional about it. You're very scientific about it, and that's just the best approach.
Absolutely, because this is part of correction of the scientific process, which leads to a recent question from Adja. What are your thoughts on retraction as a mechanism to dissuade scientific fraud? Do publishers need to do more than just retractions?
I think a retraction is a good outcome because it shows that the data in some way or form cannot be trusted. And retractions can be used also to address honest errors. So I actually really like it when a researcher discovers a big error in their paper and self-retracts. So it shows that they care about the reliability of the data, they retract it, and they can then republish the data analyzed in a better way. So I think retractions are a very good tool to show the reader that the data cannot be trusted. There's also another tool that I feel is underused, and that's the expression of concern. That is a tool that or sort of an action that a journal can take on a paper pending an investigation. So it shows that there's a big concern about a paper. There's still an investigation going. So in the end, maybe there wasn't a problem, or in the end, it might be retracted. But it's a very quick thing that a journal should and can do, but it's not used very often. I wish it was used more.
Thank you. I think sometimes you mentioned legal action. I think sometimes journals and publishers are aware of legal action themselves from those, and as are institutions aware of legal action from those who are accused of misconduct, especially those who have access to private funds. Thank you.
Right.
Natasha had some question about PubPeer. Noting there are a lot of individuals on Papier operate anonymously, perhaps understandably, and don't provide rationale for the fraud that they suspect. How do we know that these concerns are valid and that they have potential elements of malice there? And also, how do you know that people making the comments have the expertise to make those judgments? How credible is the expertise, perhaps, of those making allegations of fraud on Papier, or indeed any other forum?
Well, the Papier comments are heavily moderated. So when it's your first time posting under your account, posting a comment, there's a moderator who will look at the comments. And if the comments are not based on facts, if they're just yelling something that is just not objective, it's not going to appear. So there's a 24 or 48 hour window where the comments are moderated. Once you've been approved to comment a couple of times, so I can post without moderation because I've posted a lot, but you sort of have to, you have a test period where you're sort of checked a little bit more. So I feel that most of the comments I've seen on Papier are valid. It could be something like, I've never been able to reproduce these results. I feel that's an objective statement. And I've rarely seen comments that I feel are would not be considered to be objective. I'm not sure if that answered the questions. There are, of course, always a couple that are a little bit iffy, but often you need to have a verifiable fact to post there. You cannot just say, I think the author is a fraud. That would not fly.
Thank you. That's really helpful. A question from an anonymous attendee. Do you have any information on the false positive error rate in detected image duplication? For example, how credible is the argument that these blots look similar because they're, say, a loading control, and therefore you might expect things to look similar?
Yeah, I mean, it's hard to really know, because I find these things by eye, and so you could always argue like, I don't agree with it. So usually I will state things like, I feel these two bands look more similar than I would have expected. I would not say these things are identical, because I'm never sure. So I always build in some error rate there. But I've been told that my judgments are pretty good. That I have made a couple of mistakes in the past, but it's probably in the 1 to 2% range. So I have a good low false positive rate. But yeah, again, I try to word it as these things are more similar than expected. And of course, I have seen a lot of these blots, and so I know what the range is of. No two bands are the same. So like two faces are usually not the same. So you can usually know that bands are should not be looking so identical. And I always give the authors a chance to prove me wrong by showing the originals, and they tend to never do that. So that's I would love to be proven wrong, but it's very, very rarely that happens.
That's both good to
that
know.
Sounds very confident, right? Don't want to, but yeah.
Thank you. We're getting a lot of anonymous questions in, which I think is good, because it's useful for us of the Zoom whether or not people can ask these questions without revealing their identity. So in your opinion, what's the best way to determine whether a manuscript originates from a paper mill? So in case of your authors kind of provide data and original images, but then could just kind of churn it out. And in their experience, they say assessment of this type of work can be quite time consuming and could be a barrier to, if one paper takes up an enormous amount of time to assess, it's therefore harder to assess, you have less time to assess other papers as well.
Right. As a peer reviewer, it is very hard. There are some tools you might have as a publisher or a journal where you, for example, paper mill submissions tend to come in batches. So they're all submitted from the same IP address or from the same email, or they all have a very similar feel. But it is actually very hard to look at a single paper and know for sure that's a paper mill production. So they tend to have very general methods, so very short and not very specific details about the methods. That will be a red flag, but of course that's a very vague thing, and you can always ask for more details. You can ask for some proof that the patients really existed. They tend to make some errors, but like I've seen papers where they claim that half of their prostate cancer patients were female. That would be an obvious red flag that there's a made-up data. But of course, since we have detected these types of weird errors that they might make, they don't make those errors anymore. So they become very hard to detect, and it might be impossible. But I think it's good to sort of always read a paper again and think, does this data look real, or could it been made up? So I'm actually very suspicious of any paper I read. As a peer reviewer, it is good to have a little bit of distrust and not automatically believe what the authors are writing.
Right,
but
yeah.
it's super hard. It's super hard. Yeah.
No, I'm reminded that if things seem too good to be true, or if things have gone perfectly, clinical trials,
right,
no one ever loses their medicines and turn up for all appointments, and those sorts of things. It's always like, well, is it really that good? Thank you.
And you can always ask. For example, if it's a a thing with an error bar, like what are your original measurements. And the author should still have that, right? The data is fresh. They should be able to provide that data. And sometimes looking at these spreadsheets could show you that the data is made up.
Absolutely. I think it also ties in with other themes, what you said, and also other speakers about openness and transparency itself, just being a good fundamental practice. A couple of final questions, both in the chat stream and the Q&A stream. People asked about kind of the effectiveness of AI and automated screening systems. You know, you touched upon this to a certain degree, but how widely do you feel these tools are being used, the automated ones, and are they effective, or if publishers are relying on automated tools, are they perhaps placing too much confidence in them?
Yeah, right now the image duplication detecting tools you cannot trust them. There's always a human who needs to look at them, so they create a lot of false positives. I've seen, I've worked with a couple of these tools, so I use them as a tool, but I don't use them to rely on. So I always feel that there should be a human who uses these tools, who knows how to use them. And I've seen duplications that I see by eye that are very clear, that are not being picked up by the software, and also it creates false positives. So you cannot rely on it yet. But having said that, of course, software is going to be better and will be able to detect these things in the future more reliably. But currently, it's not. You cannot 100% rely on that.
Thank you. Yes, Paramin has just noticed in the chat that plagiarism software can also be useful, because often papers with faked images can have a high levels of text recycling, especially if they're doing the Dory thing of, we will submit our images to in lots of papers, but each time say these images represented a piece of data. So thank you very much for that. Elisabeth, this has been fascinating. I've heard you talk before, and I'm so glad we got you to come along today, because it's really interesting hearing your views on the problems and the fact that they're bad, they're pervasive, they're more common than many people like to think, but there is hope in how we can deal with them, both on the level of individual problematic papers, but also the systems and incentives and cultures that make these things more likely to happen. So thank you so much for joining us today. Thank you also to post questions in the chat. Just to clarify, I have a few questions, people asking how the questions work. I, as host, see everything submitted by the Q&A button. That includes questions where the questioners have chose to ask their questions privately, anonymously, so I can't see who's asking them. Zoom occasionally reorders them, but I try and go through them in order as much as possible. So I'm sorry if your questions haven't been addressed today, and we will try and liaise with speakers to see if we can get you answers to burning questions through other means.